Okay, here we go. Here's the Star Trek Star Wars problem. Okay, so for Star Trek Star Wars, let's do it like this. What do we know? I always start there. What do you know? I know the total of my survey, and I know that A is adult, which is 75%. Let's start there. Okay, so the probability of adult is 75%. So I need to find 75%. So in your calculator, it goes like this. 0.75 times 1200. 900. So this must be 300. So just from doing that, all of a sudden I have my breakdown of adults and children. Now if I'm just looking up here, not a lot of spots I can go. What other number do they give us? Well, we're given 558. And that's adults. It's not in the Star Wars circle. Must be Star Trek. So 558 must be adults that like Star Trek. So that's going to be 558, making this 342 because it has to add to 900. Okay, so that's a good start. And then let's go about getting the rest of our information here. So what do we know? Ooh, this gets tricky, guys. Okay, so I'm told another number down here. Okay, this must be, remember this means given that it's a child, how many of them like Star Trek? And that's 82. Okay, so this right here tells me children that like Star Trek is 82. Interesting. That one's got to add to 300. And now I've solved for all my mystery numbers. I'm going to add and add like that. Now I just get to go through and fill things in. This is probability given that it's adult, that it's Star Wars. So adult, remember that's your denominator there. And given that it's Star Wars, this here is Star Wars and adult. That would be 342 out of 1200. Okay, given that it's a child, how many like Star Wars? Or no, how many like Star Trek? Well, that's the one that was given to us right down here. Now the denominator is going to be children, which is 300. And then we have probability of Star Wars or child. So I'm going to take all the Star Wars. Remember, this is Star Wars. See how these added to 580? And then I need to add all the children. And then I think about what number got counted twice. I only want to count it once. So those are the numbers that I need to add up. When I add up all those numbers, I get 642. All right. And then I just fill in my Venn diagram. Okay, adults and Star Wars. Star Wars and kids. And the fourth number would be children, Star Trek. CST. Fill in the sentence frame with two equations you can use to determine whether two events are independent. Two events A and B are independent if what? If the probability of A times the probability of B is equal to the probability of A and B. That's the one that I've been using in the video. Another thing you can do, and you can try this if you haven't already, the probability of A given B is equal to the probability of A. That's just another way to do it. Okay. Determine whether the events are independent. I'm going to use the top one for this. Probability of A times the probability of B needs to equal this. 3 times 8, 4 times 9. And if I reduce 24 over 36, probably the fastest way, I get 2/3. Or you can test it doing that little trick I showed earlier in the video. Are these two equal? 36 times 2 is 72. 24 times 3 is 72. So the answer is yes, independent. This work shows me that you didn't just 50-50 guess it, okay? All right, so I'm going to do that again. The probability of A times the probability of B needs to equal this. 4/20 reduces to 1/5, not 2/5. So this is dependent. So we have independent and we have dependent. Data on the number of people who passed or failed their driving test the first time is below. Let's fill this in. Okay, we got to add to 25. And then this must be 31. And then this must be 14. This has to be 6, and that has to be 20. We're pretty good at that. Okay, I'm not going to go into a lot of explanation. Probability of female. So my total females is 20 out of 45. My probability of passed is, there's my total, 31 of 45. Female and passed is 14 out of 45. Passed given female, denominator, how many females are there? 20. How many females passed? 14. Passed given male, so male is the denominator. And males that passed is 17. Are the events female and passed independent or dependent? Why or why not? Okay. So that would mean the probability of being female times the probability of passing needs to equal female and passing. 20 times 31. 45 times 45. Are these equal? $620 times 45. 2025 times 14. Close, but no. So these are dependent. State whether the events are independent or dependent. Explain your answer. A marble is drawn from a bag and replaced. Another marble is drawn. So remember, did the first event affect the second event or change the second event? So I take a marble out. If I put it back and draw another one, the second time I draw a marble, my odds are the same. So that's independent. If I didn't put the marble back, my odds would change the second time, therefore making it dependent. A spinner lands on 3, and a 3 is rolled on a die. If I spin a 3, that's going to do nothing to change my odds for getting 3 on a die. Dependent. An ace is pulled from a standard deck of cards, followed by a diamond from the same deck. This is dependent. I'm giving you verbal explanations here, by the way. And it's dependent because if I take an ace out of that deck, it's gonna, and again, the key is whether or not you put the ace back or put the marble back or whatever. I'm not putting the ace back. So my chances the second time of getting a diamond card changes. So that one is dependent, and you have to write out an explanation for that, which I explained verbally. And there is your study guide.